There we go. Well, we at GitHub want to welcome you. We enjoy having you here in our space, and we want to welcome you to talk to us about other meetings and meetups if you have anything you want to use the space for. We do have a couple of ground rules and things. Please keep things clean. We've got trash and compost and recycling here and in the other room and everything. If you need something, there's myself, other community managers around and things. Also, if you see something, please say something. We don't want something to happen that says, boy, this crowd, we just can't trust them. We don't want them here anymore. So let's be a good community and all of that. But also, since we're here AI camp, I can talk about a couple of recent AI-related announcements at GitHub. Well, actually, first off, GitHub Copilot. Who here's heard of GitHub Copilot? Okay, that's what I expected. But if you need, take a screenshot, take a picture of the resources here. These are constantly being updated with new resources. Our YouTube channel, there's new videos going up from my colleagues in enterprise advocacy and developer relations and stuff like that. A lot of things about prompt engineering lately and such. So lots of great resources there. So recent announcements. Since last month's meeting, we've had some announcements. The first one is the AI-powered autofix that comes along with GitHub Advanced Security code scanning. So if you're using GitHub Advanced Security, you create a pull request. GitHub Advanced Security runs and says, hey, Dave, that code you just wrote looks like it could contain a SQL injection. In the past, you'd have to hand code that yourself. But now, with the AI-powered autofix, there'll be a suggested fix there, and you can simply hit the commit button and have it fix it for you, kind of a thing. So we just opened this up to public beta. I think it's JavaScript, TypeScript, and Python, I think that we support right now, but we'll be supporting other languages, in the fullness of time and everything. And so, yeah, check out the blog post there from just 12 days ago. GitHub Copilot is also in the command line. So in the command line, we do lots of command line operations. If you're trying to stand up Key Vault on Azure, yeah, you can do that from the command line, but that command line takes a bazillion parameters to pass in. Now you can have Copilot help you with things like that. You can say, GH Copilot suggests, I need to create a Key Vault in Azure, and it'll come back and tell you what all the parameters are you need and everything. There's other ways to do that too. If you have a complex command line that you find in a PowerShell file or something like that, you can say, hey, Copilot command line, explain this to me. And it'll give you that natural language explanation of the command and all the parameters and things like that. That is now in general availability as of March 21st. The other thing here is we first launched GitHub Copilot in Visual Studio Code. It is now generally available also in the JetBrains family of IDEs. So PyCharm and IntelliJ and other IDEs like that. Nice little demo out there on YouTube, but you can get all the details at the blog post. Finally, GitHub Galaxy. This is an event where we're going to different cities to talk about the latest and greatest at GitHub. It'll be hosted right here, May 15th. So check out galaxy.github.com for more details there and sign up. Maybe we'll see you there. Finally, enjoy tonight's event. Thank you, everybody, for coming. Like I said, we love having you here. And I'll unshare my screen and turn it over.
Thank you, Dave. Thanks GitHub for the provided space, a ton of resources. I do recommend you check it out to help you on your writing code or programming or do other projects. Great. So with that, we're going to come into our tech talk sessions today. And our first speaker, Andrew, he comes from Glean. Without further ado, let's welcome Andrew.
Sure. Can everyone hear me? The mic? Cool. Well, hey, folks, it's great to be here. Really excited about that. My name's Andrew Yang, no relation to the presidential candidate. Did feel weird putting like Yang 2024 on there, though, for sure. But I'm actually in sales at Glean. Today is not meant to be a sales pitch. I'm actually going out of my lane a little bit to talk to you about how we are approaching some of the limitations of enterprise Gen AI adoption via RAG, or retrieval augmented generation. So let's jump in. So just a bit on, I said my perspective, but our perspective as a company. Glean, who we are building an enterprise AI assistant. Really the easiest way to think about it is it's a combination of like a Google or ChatGPT, but instead of connected to all public domain knowledge, we're connected to all of your enterprise applications and content. So today we have a couple hundred customers on the Glean platform, including a number of pretty big names out there in Fortune 50, Fortune Future 50. Every day, folks like myself, Daniel and Tyler here, also from Glean, we're talking to CIOs, CTOs, heads of IT, and getting their perspective on Gen AI adoption, and which is obviously a very hot space right now. And we also have the benefit of getting the perspective of the entire enterprise, because Glean is a solution that can be deployed enterprise-wide. So it's very common that we're engaging stakeholders across engineering and support, IT, go-to-market, and really getting that full breadth of how they're thinking about tackling these problems and driving business outcomes via AI. So that brings me to like some of the fundamental challenges of Gen AI adoption in the enterprise. I think it's very clear right now that everyone is trying to get a competitive advantage by adopting Gen AI, but they're realizing now that it's a little bit easier said than done. And there's a number of pretty specific barriers to entry that are preventing enterprises from getting off to that fast start. So number one, we have connecting to enterprise data sources is non-trivial, and passing enterprise context is even harder. Two, generative AI and LLMs, they're very rarely able to stay in real-time sync with enterprise data. Three, there's no concept of permissioning within these models. So that needs to be considered by, of course, every enterprise that wants to actually adopt this in production. Four, there's obviously the concern around accuracy and hallucinations. And then lastly, there's a constant desire and ask from enterprises to have more flexibility and more controls when it comes to how they're actually putting these Gen AI tools into practice. So we'll dig into each of these a little bit more. So when it comes to connecting to data sources, obviously the typical enterprise, they have data that's scattered across all these different applications, right? You're either a Google shop or a Microsoft shop. You're probably invested in Atlassian Suite or some other tools for project management, things like Confluence or Jira. There's the IDE tools, right? Things like GitHub. And then all across the enterprise, there's other tools out there, things like ServiceNow or Zendesk that house critical information that users need to interact with on a daily basis. So considering that, customers have to think about how are we actually going to bridge our private data with an LLM, right? Do we build each integration manually? Because that's obviously a massive problem and a huge lift, and it's going to be a multi-month process that's going to take them away from like their core business focus. And different things people are thinking about is like, do we try and build delegated integrations on an app-by-app basis? But then you run into the issue of like these solutions being pretty siloed by application instead of being able to take into account like the full enterprise context for each query or question that a user has. You could go the route of having employees copy and paste, right, a document into the LLM, but like, of course, that's not really going to work in production and it's not scalable. Or you could go the route of trying to create an index of all the enterprise content. And so, it's bolded there. You can probably tell that's the route we chose. And we can talk a little bit more about, why that's important later. But the 1B here, when we're thinking about, in practice, users interacting with these models and actually getting value out of them, you need to make sure that for a given query, right, you're really taking into account all of the different enterprise contexts that is relevant and applicable. And at the end of the day, like the base models, they have none of this context, right? So there's no understanding of key terms or acronyms or jargon, right? The day-to-day vernacular that each individual employee uses, it's just not known to the LLM. And so there's an example up here, just like what does AAA stand for? And you can see like the base model LLM response is American Automobile Association, but take an example of a law firm, for example, and that AAA would mean something completely different, right? And so lastly, like we're finding that like training a generative AI model to actually consider this context is prohibitively expensive in most cases, in addition to being extremely time consuming. And so this is really like a very significant barrier when it comes to adopting these models in practice. So the second challenge here that we'll talk about is the notion of Gen AI models like not being in real-time sync with key enterprise data. So obviously, like we see from the example here, like ChatGPT, right, has knowledge up to January 2022. That's not going to fly in an enterprise context where like you need real-time data to make real-time decisions. Like take, for example, like myself in sales, like if I'm sharing outdated pricing information with a customer, like that's going to be a problem for me and my leadership, and like downstream, the effects just begin to compile. Or think about like a support team, right? If they're operating off of dated knowledge base articles, like they could be giving completely the wrong information to people on the other end that need answers now. So there's obviously like potentially very massive consequences here if you're not actually operating on up-to-date information. So it's kind of obvious and low-hanging, but it's actually a very hard problem to solve. Another big challenge is this concept of permissioning, right? So security being just a showstopper and like table stakes to really working within any enterprise. We have some generic issues here with generative AI because it treats information that it's trained on as public, and that makes it prone to potentially leaking valuable information. So goes without saying that this doesn't fly in the enterprise, right? Every customer that we work with, they need to ensure that there's one-to-one permissions enforcement. Any interaction that I have from a search context or with conversational AI needs to respect all the permissions I have within the individual apps that I have access to. A couple examples, things like should never be able to ask an AI about salary information, right, of a peer or like a boss. Or you think about like the legal ramifications that would come along with potentially accidentally disclosing PII or violating GDPR, right? We're talking massive fines, going out of compliance. Like these are huge headaches for an enterprise. And it's to the extent where they can't have any amount of this risk. Like even if something is 95% accurate, that 5% is enough that like they wouldn't be able to actually adopt and push these types of things into production. So lastly, or rather point 4 here, we have the fact that hallucination is obviously a really huge issue. And accuracy is of the utmost importance when it comes to these production use cases, right? So I think most of the folks here probably heard of that example of like the lawyer in New York who was like trying to cite cases using ChatGPT, and they were like completely false cases that never happened. I'm pretty sure he probably got fired, right? Like massive damage to their brand, like their firm has complete egg on their face. So these are the types of things that you run the risk of, and there's just no margin for error when it comes to actually like these types of production use cases. So In the enterprise, it's better to get a no answer and look for more context, ask an expert, than to be like pushing false information as potential truth. And then the last point here, right? Enterprises, they're always pushing for additional flexibility around their use cases, additional privacy controls. We think about things like content governance, right? Enterprises want to be able to limit the actual slice of data that's being exposed to these various models. There needs to be things like red listing and green listing, so they can actually select on a maybe folder by folder basis what they're actually going to be feeding to the models themselves. They also want to have a deep understanding of usage. So they need things like security tools to really log and monitor the interactions with LLMs and understand like how folks are actually interacting with them. And then they also want to be able to customize outputs by using hidden prompts in the backend. The last piece here is something that we're actually leaning into quite a bit right now at Glean, but there's this desire that we're seeing to not just interact with like a very general AI assistant, but to create agents and apps to fit very specific use cases. So think of examples like creating a HR bot, right, that can live in Slack or Teams and answer common FAQs that users have. Or things like IT bots, right, to replace pretty cumbersome multi-step IT help desk type of requirements, like how do I get a new laptop, right? These are pretty low-hanging questions that can kind of bog an enterprise down. But by automating this and pawning it off to Gen AI, like they're able to see quite a bit of benefit there. So we've talked at length about the problems. Now, like how are we really thinking about solving this and what are we seeing in the space? I think what we've really landed on is the importance of like lean on generative AI for what it's great at, right? The reasoning, synthesis, generation of content, but delegate everything else to external systems that can excel and kind of hide the blind spots or the weaknesses of Gen AI. And so that's really where retrieval augmented generation comes into the equation, or RAG for short. Really just a framework, right, where we are using the LLM as a reasoning layer, then calling a search or retrieval engine to then read limited context, pass that context to the LLM to then do, right, what it's great at, the synthesis and the content generation, and then we're able to get a cohesive response. So on that delegation of information finding, like what we're seeing is really like the foundational piece of RAG that really makes it work is great search. And so that is how you're bridging all the great enterprise context, your entire treasure trove of enterprise knowledge with the LLM. And so there's a number of like individual things that we lean on search for at Glean. The first piece being like, obviously the search index, right? Act as that knowledge base. Don't rely on the LLM whatsoever for that piece. Number two, we have the actual passing of that rich context to the LLM to help us understand, hey, what's going to be the most relevant bits of information for a given search? And it really helps us with personalization and ranking. There's also this element of mining company context as well in this example of index search. And then the notion of, because we're able to lean on non-generative models as part of this the search piece, it actually speeds our ability to learn and continue to fine-tune these models. So moving on, some added benefits here to this approach. We're able to greatly increase the quality of the results and reduce hallucination. This is kind of walking you through some of the steps that are involved in that. Don't need to read through all of this, but the gist is by leaning on the search piece, the RAG component, and combining both generative and non-generative models, or LLMs, for their respective strengths, we're able to ultimately boost quality pretty significantly here. A few more benefits of this approach. We now can stay in real-time connection with all the various source applications that we spoke about, either by keeping a real-time search index, which is what we do here at Glean, or by via delegated API calls to that search index. The second piece, right, we have the ability to now enforce permissions, which can be stored either natively in the search index or do, again, real-time API calls to those source systems. And then the last piece that this unlocks is the ability to actually chain workflows in multiple steps. So one of the things we're working on at Glean is taking the conversational AI component from more of just like a confined read-only experience to one where you're actually able to take actions and do things like ask a chatbot to create a Jira ticket or schedule a calendar event, things like that. So this is ultimately like the architecture that we landed on at Glean. It's a bit high level, but what you can see is like on the left, we have the user interacting with the chat interface, right? They input a query. Step two, we're analyzing what that query is. We're then prompting the LLM to actually translate that query in a way that Glean can understand and we can utilize. We're then breaking that query down into component parts and basically conducting searches against the search index. That's the phase at which we're layering in all that rich enterprise context and all that data that we've mined, right? And step four, right, the intelligent data selection piece. We're then passing snippets from those most relevant results to the LLM itself to then synthesize and generate a cohesive response based on what it's found. So all of this nets out to an AI assistant and search experience that's basically ready to serve users with the knowledge they need on demand and what they need to do their best work day to day. What we found is like building this in practice is very hard. There's a lot of technical complexity that goes into it. And there's a lot of like Fortune 100 companies that we're working with and speaking to now that have ultimately invested in Glean because we can provide this retrieval engine as well as this knowledge graph capability out of the box. So key takeaways here, Gen AI is super powerful, but not a magic bullet by any means. Lean on it for its core strengths, but make sure that you're also acknowledging its weaknesses. Two, focus on accomplishing a majority of that workflow without the Gen AI, right? So that's where RAG comes in. Really have a strategy, a story around the search piece, maintaining that index so you can consider a lot of these or navigate around a lot of these challenges. And then the last piece, RAG is just the beginning. We fully expect to see a rise of AGI across the industry, which in our world is augmented generative intelligence. So, and that's it. Thank you. Oh yeah, sure. Take a couple questions.
Cool. Hey, I'm Val. I'm at Roblox. We use Glean as well, but specifically on the part where you said to minimize hallucinations, where you check like the context for like whether this is real data or not. Is that like similar to like when you ask ChatGPT to generate some data, it outputs you like a list, and then you ask it, hey, what did you get the sources on like all these 5 things? It'll actually give you like sources for some of them. The other one is say, oh, I kind of made that up based on my knowledge. Is it like a similar process?
Yeah, I'd say so. One thing that we guarantee in all of the responses that what we call Glean Chat is giving to the user is that everything is source backed. So none of the responses that they're getting are being hallucinated because we are actually citing line by line where those answers are being grounded in the enterprise data. So yeah, and it's providing clickable links basically to like we pulled a snippet from a particular Confluence page or conversation in Slack or Teams. It's actually showing you exactly where every bit came from. So yeah.
A question about how do you handle queries that relate to people in the company? So a lot of times the best answer is not here's such and such document and a summary of it, but the best answer is go talk to Tyler in receiving because he has the right answer. Yeah,
it's a great question. Man, I would just so love to give you guys a demo, but I think I'd get in trouble. But yeah, part of the knowledge graph at Glean. So we do a lot of work in understanding not just the content, but also the people data and how they interact with that content. So there's a lot of signals that we're mining across the organization, especially in comms channels like Slack or Teams, to understand who's an expert around particular topics, right? Who's authoring documents, who's talking about documents in an authoritative way. And that allows us for a given search to actually indicate, here are the top search results for that search, but also here are experts who are talking about it, writing about it. If you have follow-up questions, you can go to them. So that's something that we expose in the UI. Yeah.
What are the limitations that you see in the knowledge graph and the RAG approach as far as the type of data that you can reference and index? I'm thinking about things like AutoCAD, mechanical engineering, and so forth.
Yeah, we are definitely considering how to take different types of media into account. Like today, it's largely text-based, and then we have the ability to do some OCR as well. But there's definitely some limitations with respect to some of those more bespoke tools. We're typically approaching those on a case-by-case basis with customers, and oftentimes it comes down to building custom integrations to index that content in a way that's then going to be usable and meaningful. So,
thank you for the talk. Actually, it was a follow-on question to the other one. How often would you update your knowledge graph? And if I may, a second question, because another talk is coming up talking about long context queries. How would you contrast RAG with the long context in LLMs?
Yeah, that's a good question. I don't want to answer it just because I'm not an expert around that. So I don't have a great answer for you. But yeah, sorry about that. Yeah, so part of, yeah, he's asking how often we update the knowledge graph. So that's something that is happening in real time. So as the enterprise changes and works day to day, all this knowledge is changing as well. And so we feel it's important to take all of that into account. So we basically are rerunning the ML pipelines about every 15 minutes or so to ensure that we are staying up to date with permissions and the latest content and taking all of that into account.
So I have a follow-up question. So I know that there are companies that building their knowledge graph too, like Zillow. So for those companies, I guess you can just use GPT API on top of their knowledge graph to achieve the same system that you did. So for those companies, I wonder how the search system that you have make you distinct and make you a good choice for those, rather than just use their in-house knowledge graph and build an GPT API on top. Thank you.
Yeah, that's actually the exact approach we take. So I think like if a customer was to come to that conclusion and they had the technical resources and expertise to build it themselves, we'd applaud them. What we actually find in practice is that most of them end up coming back to us because it's just technically a very hard problem to solve. And it becomes a pretty expensive science experiment pretty quickly. And they realize they can partner with a third-party vendor to get the value in a matter of a week or two, or they can go down a pretty costly road of doing it themselves, and they might be successful, but it's going to sidetrack them from their kind of core business objectives there. So,
are you working with embeddings and semantic search at Glean, or is it mostly just a RAG?
Yeah, it's a combination of hybrid search, embeddings, RAG, all of the above. Yeah.
Are you working with a large repository like Pinecone then for your embeddings storage, or are you hosting all of that in-house, or do you rely on the enterprise to host all of the embeddings?
Yeah, that I'm actually not sure on. I know we're not using Pinecone, but I think it's done in-house on our end.
Yeah, how do you guys do like say permissions for questions to HR orgs? Like how much retirement time do I have? How do you prevent it from, I'm not asking from someone else, I'm asking for myself, or, how do you enforce that?
Yeah, there's definitely some limitations. Like it's certainly not a magic bullet what we've built. So as we are enriching like our connector story with those types of applications, like on the HR side, we're able to deliver on a bit more of that. But today, I wouldn't actually be able to, like, we're not actually indexing that content, like on a user by user basis, like how many days of PTO has a user used. So you wouldn't be able to query against that. So in our world, because that's not something that we have access to on the data side, we would just return a response that, we don't know.
Okay, good to know. Thanks a lot.
Yeah.
Great, thank you. Okay, the last questions.
Are you storing context of somebody's search so that the Gen AI is getting better at answering their question? Are you doing any of that?
Yeah, definitely. So that is like on a session by session basis, something that we do, very similar to like the ChatGPT experience, where we have all the context from that session of interaction between a user and the AI that's being stored in Glean. Yeah.
All right, thank you so much. Let's go on. Okay. If you ever want to run the president, let us know. We're going to vote for you. All right, so let's move on to our next speaker, Aiden. He's going to talk about LLMs. And where is Aiden? All right, here. Okay.
It's working. Okay. Thank you all. I have to tell you, it's a great privilege to follow an opening act by no other than Andrew Yang. So thank you, Andrew. My name is Eden. I'm not trying to get to 100,000 LinkedIn followers, but if you want to connect and you have interesting comments or questions to share with me, then by all means, feel free to do that. I'm a product manager at Google for generative AI, and my expertise is large language models. So today we're going to talk about LLMs, not for the first time, and we'll focus on a new wave of LLMs, which we call long context LLMs. And it's great that we're following a topic of RAG, because as you will see, this is a different angle to look at some of the same challenges. And when we talk about long context, we have to explain, I think, what context is. So we'll start with that, with your permission. Then we'll talk about how long context has been evolving for the last, I want to say years, but everything here is about months and not years. So for the last few months, how it's evolved. I'll talk about use cases, including some really cool enterprise things. We'll see a demo of a long context LLM and what it can let you do in your personal and private life. And if we have time, and I'm not good with time, so we'll see if we get there. We'll talk about multimodality, which is pretty key to long context, or the other way around. And lastly, I think it was your question, right, about RAG. Maybe I can answer the question that Glean was asked. So what's context anyway? I think you all know that LLMs speak the language of tokens, not words. Tokens are pretty close to words, not quite the same. Usually they're about 3/4 of a word. And this is the basic unit of accounting for LLMs. They process tokens. The input is made up of tokens. And if it's not, then you tokenize it. So it's all tokens. And it produces tokens one at a time through what we call auto-regressive generation. The LLM sees a chunk of tokens and generates or predicts just one token. And then we take that sequence and feed it back into the LLM, which sounds like a really stupid way to do things, but it will produce another token. And we keep doing it until it produces the end of sequence token. And that's how we know the LLM thinks it has a complete response. All this stuff has to fit into what we call the context window. So the context window measured by tokens is the number of tokens that consist of both the input that the LLM received, which you can think of as the prompt, and everything the LLM has or will be producing in its response. So both the prompt and the generated output. And the reason this is so is because LLMs have no statefulness. Every time they produce something, they only see the prompt that's provided to them. They have no working memory other than the prompt. So the context needs to be long enough to provide any kind of information that you want the LLM to know beyond what it was trained on. Okay. Who in here has heard about or used chain of thought prompting? Raise your hand. Okay, about 30%. Let's say 60% for those who don't raise their hands at events like this. So a good chunk, a majority. And chain of thought prompting is basically asking the LLM to break the problem into smaller chunks, decompose it, and then try to build a solution step by step according to some recipe or algorithm. Just like if I ask you to add two long numbers, if you just try to spit out an answer, it's probably not going to be correct. But if you try to do long addition, then it takes you more time, you need a scratch pad, but you're more likely to complete it successfully. So we see LLMs behaving the same with highly analytical problems, which are not about remembering a fact, but about reaching a conclusion. But to do that, we need the LLM to write and reflect on its own output. So we need a context window large enough for that sort of reflection. We usually think of the context window as large enough for the input, but it is increasingly more and more about the output. And okay, that's great. Let's just increase the context window. Apparently, there is a little bump in the road when you try to do that. So I don't know when you took your Transformers 101 class. I'm sure it wasn't an easy one, but there is this component which we call the self-attention mechanism. And this is what creates and calculates and computes the relationships between all the different tokens. At the heart of it are three pretty massive matrices, which we call the KQV matrices, key query value. Raise your hand if that sounds familiar. Okay, I didn't lose all of you quite yet. Working on it. Okay, the K1 has a number of rows that is equals to the context window size, or the number of tokens provided to the LLM. And a number of columns, that's the dimension of the hidden space. That's usually some kind of fixed number like 2000. And to create that attention, we take the K matrix and we multiply it by a similarly sized matrix called the Q matrix, but we have to transpose it because the dimensions have to fit. And then we end up with a new matrix. We call it the attention scores matrix. Now it has both the number of rows and the number of columns. So both dimensions are the number of tokens in the context window. And what that means is that if you double the context window, now the number of elements in the matrix, they don't double, they quadruple. Okay, so you have this quadratic relationship, both in memory, because we have to store this matrix, and in computation, because we're not done with that matrix. We're going to do softmax. We're going to multiply it by the V matrix. It's a very exciting thing to do if you're a GPU, but otherwise it's a lot of work, okay? So that's why we don't see context windows of billions, because it's just very, very difficult and expensive to do that. The early LLMs like GPT-2 or 3 had about 2,000 tokens, to give you an idea. So their entire state is just 2,000, not even words, but less than words. Mainstream LLMs today are in that region of 8,000 to 32,000. So still quite constrained, better, but quite constrained. And it's all because of this computational complexity explosion that comes from the self-attention mechanism. Good news, people are working on it. Really smart people are working on it. And they're making some really decent progress. Just in the last couple of months, these are some very seminal papers on the topic of context. I would say that if you look at the top 10 topics of research in Gen AI today, along with alignment, hallucinations, and so on, context is probably one of the top 10. So it is getting a ton of attention. There are some really brilliant ideas of how we can maintain the quality while increasing the context size without killing or consuming way more energy or much more time or memory. And the good news number 2, is that a lot of this research is already percolating into the LLMs that are available today, either in preview or even production grade. So I expect the context to continue to rise, and we're already seeing some of that in the market. So last July, that's prehistoric by LLM standards, but it wasn't that long ago, really. Claude 2 came out, a pretty good LLM, and it was the first LLM to proclaim to have long context. So that was 100,000 tokens. With 100,000 tokens, that's equivalent to what you can read in 5 hours. So think of providing the LLM a prompt, which a human would need 5 hours just to read through, to say nothing about synthesizing, making sense of it, just reading it, 5 hours, that's pretty good. So that was July. OpenAI promised us long context for a very, very long time. And finally, in November, they came out with GPT-4 with 128,000. It was in preview, it still is. Claude 2.1 doubled this. And a few weeks ago, we at Google launched Gemini 1.5 Pro in preview. And it was groundbreaking in the sense that we hit the 1 million token mark. And in fact, in internal research, we use it with millions of tokens, and it scales decently. It's not exploding. One issue that we've seen with long context LLMs, if we take a look at Claude, which was even Claude 2.1, not the first long context one from Anthropic, it had a recall problem. And when we talk about recall problems, we mean that as you use more of that long context, the LLM seems to miss various things scattered inside the context. So this is an interesting benchmark called needle in a haystack. So imagine you feed Claude with 200,000 tokens, say a book about penguins in the Arctic, and somewhere inside that, you bury a little fact about Andrew Yang. Okay, I don't know, you're in front of me, so I'm using you. Just a few words. And then you ask the LLM something about Andrew. What this benchmark tells us is that depending where you bury that little needle, that needle fact, if the rectangle is red, in their testing, the LLM was unable to pick up on that little tidbit. It's as if it never existed in the context. So that's not really great. If you have long context and the LLM is ignoring big parts of it, how useful is that? Well, good news, Gemini, we solved it, 99.7% recall rate. So essentially the entire benchmark is all green. And I think others will follow suit pretty soon. So now we have really long context and really good recall rate. What does that let us do? With 1 million tokens, we can do 700,000 words, which is the entire Harry Potter series in one prompt, the entire series, or 11 hours of audio recordings. And that's not the transcription. That's the tone, that's the vocals, that's the sonic attributes of the recording, so everything. And we know that verbal communication is a tiny piece of all communications. 1 hour of video, 30,000 lines of code, it's a pretty big project. So let's see a hypothetical, not hypothetical, I mean, this is a real example, but I'm not gonna demo it to you. Long context means we can pick something that's not in the training data of the LLM. It could be enterprise data, but in this case, we took Calamang, which is an extinct language from Papua New Guinea or thereabouts. No LLM was trained on Calamang because there is not enough training data on it. And we know because we can ask it to translate something from Calamang, and no LLM will do that. What we did here is we gave it a tiny task, translate the following from English to Calamang, but then we dropped two other things into the prompt. We dropped a grammar book describing and explaining the grammar rules of this language and a dictionary, English to Calamang. 250,000 tokens. So we're not even scratching the 1 million token mark. And we're telling it, read through these books, learn Calamang, and you got 30 seconds. Tell us how you translate this to Calamang. And it did a good job. How do we know it did a good job? Because we then fed it the reverse way and asked it to translate from Calamang to English. We ended up with the same thing. So that's an example of a gimmicky, but pretty exciting use case that long context allows you to do. Let's talk about more concrete and substantial things with long context. One category of things is things we already use LLMs for, but now we can fire on all cylinders. So summarization, we love summarizing things with LLMs and they do a good job, but we're limited by how much we can cram into that prompt. So we have to chunk and dice and use hierarchical summarizations, and that's all messy. With 1 million tokens, we can summarize the entire Harry Potter series all in one go. That's nice. Or any corporate documents. We can provide a number of documents and ask any question that we want about them. With RAG, we can kind of do that, but after we index the document and do the similarity search and all that fun stuff, we pick one little passage from the document or the book, and we tell the LLM, answer the question using this passage, which is great. If all the information is in this passage, you get a good response. But how do you know if it's all there? You're just picking the passage that has the highest similarity score, but that doesn't mean no other passage attends to that topic. So long context, no need to worry about it. Writing completions. So here's the email I wrote, or here's the manuscript I wrote. How would you continue this? LLMs let us do that, but they usually look back a few paragraphs, a few pages. Now you can give the LLM your manuscript at page 300 and basically tell it, read the first 300 pages and tell me what page 301, 302, 303 all look like. So no limitations there. And chatbot related apps. So in the early days of Bing AI, people were complaining, you speak to Bing, or you converse with Bing AI, and after a few back and forth, it seems to forget anything that was said. And it's understandable. The context window was just 2,000 tokens. How much memory can you give Bing AI when all it can look at is 1,500 words? So this is really great for multi-turn conversations because it allows you to not only look at the current session, but really any previous session. So if you want continuity between my conversation today and last week and the last 2 months, it can all fit into the same prompt. Very useful. But then there are entirely new use cases that long context lets us do. So one thing is write long form content from scratch. So we talk about prompt to image generation. What about prompt to book generation? That's totally possible. And if you think, well, but I can do 10 pages of the book with ChatGPT, the regular one, what's the big deal? Yes, you can do that, but every time you have to give ChatGPT the content that it needs to continue. But if it can only look at the past 10 pages, how coherent is that really going to be? Coding-related exercises. So think of feeding an entire project and asking the LLM to do a vulnerability analysis, for example. And the LLM not just can do more than just look at the current routine or file. It can navigate through the maze of different dependencies in the project. Now, I'm not saying this is the future way to do vulnerability analysis, but the long context means the LLM can absolutely travail through all the tokens in the prompt, and it can do that many, many times. In fact, when we talked about the transformer, what I talked about, all these matrix operations and stuff, that happens more than 100 times for every token. Transformer has a ton of blocks, and so there are a lot of these iterative processes looking again and again through all those different tokens. So for a code review, that could be quite useful. Legal use cases. So imagine you're working on a contract, but this is not the first contract between you and Acme. You have 20 other contracts from the past. And usually you have to know what was in previous contracts because you don't want to contradict them. Maybe there is a sunset clause that you now need to think about. So you have to read through all these other contracts. Now you can dump all the contracts into the same prompt and ask the LLM either to help you write the contract, to tell you what contradictions might arise. Are there any stale clauses in any previous contracts that you should now take a look at? So all these things are possibly in one single prompt. And last, RAG is very useful for is fact-checking. So we know these LLMs have a tendency to hallucinate, but they have a much lower tendency to do so if we give them grounding information in the form of a passage, a document, and we tell them, please answer based on the following text, and I want you to cite and provide attributions to it so I can double check that what you're telling me is correct. So now you have the corporate policy about how to deal with suppliers. Every time you have perhaps an email with one of your suppliers, you can include the policy, and before you hit send, you can ask, is there any violation of the corporate policy? And if so, point out what it is, for example. But the main thing I want you to take away from this is the big use cases will come from you guys, from users, developers, enterprise architects. We don't know what the use cases are. We just know there's this incredible capability. What to do with it is up to every one of us here. And long context LLMs are coming to a place near you very, very soon if you don't have one already. So with that, let's do a live demo. I'll switch the screen. Okay. And I need, let's say, 2 volunteers. It's a really easy thing. 3 volunteers, let's say. Who wants to volunteer? Okay. So I'll tell you what we're gonna do before. We're gonna take, yeah. So, okay, you can see, okay. So this is my aging car, and recently I've had to go to the instructions manual more and more for various issues. And it's a long manual. I think we need to see how many pages, but it's really quite long, hundreds of pages, 284 pages. So what we're gonna try to do here is we're gonna pick a random page, and I'm doing this in a distributed fashion, so there's no like 51% attack or something like that. I have no way to know what we will end up with. And we'll give the LLM the entire instructions manual, which is really very long, and ask it some random question that will clearly not be possible to answer if you're not looking at the manual. So you are the first one. Can you pick a number from 0 to 2?
0 to 2?
Yeah, that will be the hundredths digit of the page we're gonna go to. Yeah. 1. Okay. Second volunteer? Yeah. Wow, 0 to 9. Okay, 1, 7, and we need 1 more digit. Who wants to give us that? Yes.
3.
Okay, page 173. Music collection, that's actually pretty good. Okay, so let's pick some random fact. And, oh, there are patent numbers. Okay, I like that. That's super random, right? Okay, so one thing we can ask is on what page does the manual reference this particular patent? That's a needle in a haystack type of challenge. So let's do that. Let's see. We'll look at something more interesting later. So this is the Google AI Studio. It's a playground that you can use to test out various things. Based on this manual, or, whoops, okay. Okay, let's attach that again. Looking at this manual, on which page does it reference this patent? And this entire manual is only 130,000 tokens, so we could do much more than that. So that's Gemini 1.5 Pro. It's in preview, but a lot of developers are already using it. What was the page number? Who remembers? 173. Okay, well, it got it pretty close, 172. Oh no, it is 172 because the PDF probably starts from page 0. So, okay, good job there. Okay. Let's do something a little more advanced. So it supports these different formats. It's an old car, okay? I'm going to take one out and ask it, which other format does the music, I guess, collection system support, okay? The music collection system supports 4 file formats, but I forgot which one the fourth is. The first 3 are, okay, so it's AAC. Which one is the fourth, and where do you see it in the document? So this is now going to process the document again. In fact, it will process the entire conversation again, because that's generally how chatbots are built. Interesting. Try again. Okay. Yeah, so it got it right. AAC, page 172, and it gives us a highlight of all the file formats. So this is how powerful a long context LLM can be. Yes. So this is not in the document, right? So you want to ask it how we, okay, so let's see. Okay. Based on the manual, how can you store or read? Maybe play? It says store. Oh, yeah? Okay. Store files or music on a Blu-ray disc? Yeah. Okay. Because it can do DVD, but cannot do Blu-ray. Yeah, so the correct answer is the manual doesn't state that this is possible, right? I mean, I can tell you, this is an old car. I don't think we had Blu-ray back then. Does not support. Okay, the manual explicitly lists playable format on page 166. Blu-ray is not included. Let's do one final check. Page 166, it claims. 166. So yeah, it seems to talk about playable formats, and indeed, Blu-ray is not part of that. So thank you, Gemini. Good job. You didn't embarrass me. A quick time check. Should we go on with a couple more slides or questions?
5 more minutes.
5 more. So let's take questions. Is that okay? Yeah.
Is it able to infer or deduce what? So you listed the patents when we started. It would be interesting if it could list what Google or Gemini, tell me what these patents relate to in this manual. Technologies that are patented.
I would say try it at home. We encourage you to try it at home. But given that, by all accounts, LLMs are trained on patent databases and they are in the public domain, it is very likely that it knows a lot about every such patent.
It's just another degree of inference. Is
Yeah.
Kind of what, or deduction.
Yeah, good point, yeah.
How does,
yeah, microphone. Yeah.
We want to make sure we use the microphone so the recording picks up the questions for those that are watching at home.
So Eden, you're on the product side. Did I just watch you blow through like $500 worth of GCP credits?
Yeah. That's the sales people, not me.
Fair enough. Is that generally a fairly, I mean, do we have an idea of how expensive this sort of product is going to be? Choose your own units. I don't care. But.
I think based on, so I can't really talk about pricing because I don't exactly remember. But what I would say is that you do pay by the prefix size, which is the input that you provide, and the output. Usually you pay more for output tokens than input tokens. I think if you look at the mainstream pricing, it's pretty cheap. So 1 million input tokens usually go for less than $1 for most LLMs, much less, in fact, than $1. And the price drops so quickly that I think since ChatGPT 3 was released back in late 22, the API. And today, at least their pricing went down by like 98% per token. And you know, the industry sort of follows the same trend. So it's pretty cheap, yeah. Yeah.
Hold on.
What hardware is used to underneath this technology? Do you know?
I mean, at the end of the day, it's all GPU-based stuff. So we're talking about ML accelerators of various types. Google itself, I think, you know, we use the tensor processing unit, which is kind of our design. Yeah.
Thank you for the talk. Again, very interesting. If you could address the RAG and LLM, long LLM context.
Yes, let me talk. And yeah, I think that's a good question to end with. Yeah, another
but I'll
one.
squeeze in another one. So you have 1 million tokens context window, and you were processing, let's say, 130K tokens. But in the back end, you still process 1 million tokens. Is that efficient, inefficient?
No, no, you do not process more than you need.
Okay.
The utilization is based on what's actually used. And you can feel that when you provide a shorter prompt for almost any LLM, they will respond more quickly. So you have to design the system for the maximal size of the input, or basically the maximum context window. But it would be very inefficient if you always used up that entire space. Yeah. So you don't do that. In terms of RAG, so, well, now we know, thanks to Andrew, what RAG is and how it works. RAG has an advantage where if you want to really use the LLM at a large scale and you want it to respond very, very quickly, RAG is still the preferred way to do that, most likely, because you can keep your prompts very short. The vector database itself is very fast. I mean, depending on how much you have there, but that shouldn't take more than milliseconds worth of time. And you will probably save on some costs. But it's exactly the kind of thing where there is a break even. So depending on how heavy your usage is, I think for everybody right now, if your task can fit into, say, a 1 million context window, and not everything can fit into 1 million tokens, of course, you have enterprise data that takes petabytes. But assuming the grounding information or the reference that you need to complete the task fits into 1 million tokens, absolutely start designing and developing with long context to see how to do that. Can the LLM even do that? Once you get it to work, you can start thinking about, is it fast enough? Is it cheap enough? Do I need to optimize it? And maybe then you go for RAG. But given that you have these capabilities today, you should certainly start with what's easiest. This is as easy as it gets. You don't need any expensive environment. You don't need hardly any expertise other than prompt engineering.
So how do you handle the images? So if you have some question for images, so how do you embed it, or how do you embed the information on images?
Yeah, good question. So we didn't talk about multimodality, but Gemini and various other LLMs are multimodal. That means they can take images, audio, text. The way it happens is we tokenize this information. So we take an image and we turn it into tokens. Usually the image can be broken down into either patches or other sub-images, think of it this way, and each one gets a different token. It's really important that as part of the training, you also train the model on a lot of multimodal data so that it creates and establishes these relationships between images and the captions that come with them and the text that comes with them and so on. So images can be processed in the same way as language, given the right encoder.
All right, I think we are run out of time. So I still see a lot of showing hands. Unfortunately,
I'll be here if people have questions after.
You probably can stay after the events, have asking more questions. So let's go on our pause. Okay. Thank you so much. Great. Move on to the next speaker. Is Sergii. Come on. Yeah, we're going to shift to the topic a little bit from we heard a lot of today about the LLMs and the RAG, and Sergii going to talk about the PyTorch. Oh, join the, I'm sending the emails. You can join the room. Yes. Yeah. Minimize so on the taskbar. Just join.
Okay.
You can use it.
Hello, my name is Sergei. I work at Meta on PyTorch developer experience, and I will talk about TorchFix. This presentation will be much lower level than the previous one. There will be actual code, but hopefully it's not too scary. Right. And what is TorchFix? TorchFix is a linter for users of PyTorch, for people who develop AI. And to be clear from the very beginning, like TorchFix doesn't have AI. It's a tool for developers of AI. And yeah, just to get started, how many of you, raise your hands, use PyTorch, code, read or write PyTorch code? Oh yeah, quite a lot. So I want to describe what kind of problems TorchFix want to solve. And these problems should be familiar to people who write and maintain code in PyTorch. It's more about maintainability. So first example. So Cholesky decomposition, it's a function in PyTorch. And the old name was torch Cholesky. And after some changes, like torch Cholesky still exists, but new name is torch Linux Cholesky, and it's not only name change. So they actually change semantic a little bit, right? So now you may need to add upper value. So if you had upper value equals true, now you need to do this MH at the end. You need to transpose the matrix. So another thing, and this is actually funny. So in PyTorch, you can say that you don't require gradients for some parameters. And you do this to actually save resources. So you don't want to train on this data. And in many cases, for example, if it's only for inference or something like that, you can say param requires grad equals false. And if you forget the S, right? If you just say param dot require grad equals false, you will not get any errors. But your system, your training, your inference will be running slower and will consume more memory. And this is not hypothetical. Several pretty large repos and some models from benchmarks. I don't want to point fingers, but yeah, some models from benchmarks had this issue. And it's kind of hard to find. Another example, in data loader, you can specify a number of workers to do stuff, to load data in parallel. If you don't specify any workers, it's assumed 0 workers. Basically, you do no multi-processing. You do your data loading in the same process where you process data on the CPU. And you don't want to do this on production, right? In production, you really want to specify number of workers to some number, probably number of virtual CPUs on your machine or something like that. And you may want to tune this number. But the main thing, you need to provide some number here. Another example, TorchVision is a popular domain library for PyTorch. And they changed the API recently. So previously, if you want a model with already pre-trained weights, you provide pre-train equal true. But that doesn't really work because you can have several variants of the model. So we need something more than a Boolean. So TorchVision developers came up with a new API where you actually specify weights. And if you don't specify weights, it equals the same as pre-trained equals false in the previous case. So how to solve this, right? So you can just manually go to your code base when you get new version of PyTorch or TorchVision or whatever, and fix that. But in many cases, it's just hard to find, as I said, for required gradient. And in many cases, it's just too tedious, especially if you have a large code base. So what we developed, it's a static analysis tool. As I said, there's no AI, it uses libcst. So it parses Python, and then there are handcrafted rules that process abstract syntax tree and creates warnings or even autofixes. We call this autofixes code mods. For some cases, we can have these autofixes to actually just fix the code. And I have a link to this library libcst, and actually there is a small demo. There is a site called libcst.me, and just to show you what it does, right? So it's a import torch, and it creates a new node with an import and has import alias and everything. And if you're familiar with Python AST, there is a difference in libcst because libcst is a concrete syntax tree, opposed to abstract syntax tree. The difference that you have a white space after import, right? Comma equals default. So in addition to abstract syntax tree, libcst catches all the comments, all the white spaces, all the commas, optional stuff, and you can actually parse a piece of code and then convert back your CST into code, and you will get the same code. So it's like there is a guarantee that parsed code converted to code back, you get the same code. And this way, it's much more convenient to use libcst compared to Python AST when you want to actually modify code. The autofixes I was talking about. And TorchFix has two mods. So if you're familiar with Flake8, it's a very popular linter for Python. TorchFix can run as a plugin for Flake8. So if your CI, for example, already has a Flake8 integration, it's very easy to integrate TorchFix to it. I actually wanted to show you how I did it for one project as an example, right? So this project already used Flake8. And what I did to add TorchFix, I just specified that now we want to also select TorchFix rules. They all start with TOR. And additional dependencies, TorchFix. And in this Flake8 plugin mode, it's very easy to add TorchFix to CI. As I said, as I showed, maybe just 1 or 2 lines of changes. But also there is a standalone mode. You can run TorchFix as a script, and then you get autofixes. Actually, have a small demo. I've cloned a repo called Nemo from NVIDIA. This is a very popular repo. And you do pip install TorchFix. I already installed it, but anyway. And now we are in this repo, we do TorchFix. And it takes some time on this machine because it actually needs to parse Python into concrete syntax tree, and Nemo is a large repo. but you can see there's the output. So let's go to this. The first one, Tor 102. This is just an error code. And it says that torch load without weights only is unsafe. So this is actually a security issue. It was actual security issue that was live in real life, where people uploaded bugged models or like compromised models. And when developers try to use those models, they download them. And actually, if you don't use weights only, this is a pickled Python. And pickled Python is just Python. It can be anything there. So when you just load this model in PyTorch, it's not actually data. It's actually Python and can lead to like anything, basically remote execution. So you should provide weights only parameter, make it true if your model doesn't need this. In some rare cases, you need to provide false if you actually use this pickle functionality. So there are several changes like this, several violations like this. Another one, use of deprecated function. So this function was recently deprecated. There is a link you can click and learn more about this. What else we have? Yeah, another one. It suggests to pass user entrant value to checkpoint. And if there is an asterisk, it means that there is an autofix for this. And here, autofix is actually provided. So you see minus, so we want to remove this line, and we want to add this line. And the difference is weights only equals true, and so on. And to apply these autofixes, to be clear, not all of the autofixes will be 100% working for your use case, because it's not possible to know the intent, but this is a good starting point, and in some cases, it will actually be fine. So to apply these autofixes, you just do minus fix, and in the end, it will create, it will change files, and you can do git commit and create a PR and merge it, and it will work. And I actually used TorchFix to create PRs to some popular repos. For example, this repo is GPT fast. And see, this is the PR, basically just add weights only equals true. And this PR was auto-generated. I just used TorchFix. And what else we have? Yeah, so this is another repo, Kineto. It's a profiler for PyTorch. And this PR also was auto-generated. It's a little bit more complex than the previous one. And this is another one. This is for Hugging Face transformers, actually. I'm sure you know about Hugging Face transformers. So here we update old range function to new arrange function. You just need to change name, and now it's not inclusive, so you need to increase by 1 the right border of the range. So how to install it? As I said, you can just do pip install TorchFix, or you can clone the repo and install from repo. So here is the repo. And the current stage is a beta version, but it's pretty used internally at Meta and outside, and Hugging Face transformers, as I said, like accepted APR and some other famous, like popular repos. And it runs in CI of several projects, mostly Meta projects. So it's already like, I think, good enough to try. And in future, we want to add more rules for different issues, add more configuration options. Right now, TorchFix want to have like the latest PyTorch. It assumes you want to use the latest PyTorch, but for some projects, they want to use some range of, be compatible with a range of PyTorch versions. So right now it's not supported, but it will be soon. We want to integrate more with PyTorch documentation and CI. For example, if the vision is that if PyTorch function is deprecated, then there should be a rule already at that point in TorchFix for that. So you cannot deprecate PyTorch functions without TorchFix. We are not there yet, but it will be very convenient for users to actually update to new PyTorch versions. Yeah, so this is a repo again. It's PyTorch Labs TorchFix. And contributions are very welcome. We already have some involvement from the community, not only from Meta. There are issues. You can create your issue. You can create a pull request. You can try to solve an issue. Yeah, and first task, like to try to use TorchFix on your own project and see what it says. Maybe you'll find some interesting things and maybe something to report back to TorchFix. Thank you. Questions?
Do you have any intentions to write a plugin for Rough by any chance?
Sorry?
Do you have intentions to write a plugin for Rough, RUFF?
Yeah, I get this asked from time to time, right? So, yeah, to those of you who don't know, Rough is a linter for Python. It's very fast compared to Flake8, for example, and it's written in Rust. And we actually use Rough in PyTorch CI. So my hope is that if TorchFix will get popular enough, people who involved with Rough will take it and implement in Rough. That's what happened with a lot of Flake8 plugins, because I'm not that familiar with Rough and with Rust, and a lot of people who work with PyTorch, they're much more familiar with Python. So it's much more natural to write rules in Python. But yeah, if someone wants to take the logic and re-implement in Rough, actually you can use libcst in Rough. So many of the rules will be logically the same. And I suspect performance will be also not that much faster because we already use libcst and libcst implemented in Rust. So the answer is that I'm not planning to do it, but if anyone wants to do it, yeah, go ahead. I will help you.
So for the TorchFix, do you adapt it to the environment like the, for example, training data or the hardware like the GPU? For example, like if you detect the training data, the input is very small, maybe use the maximal sequence length to very large number is not a good option. Or for example, we detect use we have 4 GPUs, but it in the code doesn't specify the distributed training, so we can fix that. Do you do that kind of thing?
Yeah, there is a plan to implement at least one rule in this vein. So the idea is that if we look at the GPU capabilities, and to be clear, TorchFix itself don't run on GPU, right? But you can look what GPU machine has, or you can provide a parameter in future. Right now you cannot. And the idea is like look at the capabilities of GPU, and if GPU have some particular capability, basically any recent GPU, I forgot exactly what the logic, but like don't use something, right? And yeah, there's definitely a family of rules that can be dependent on the GPU capabilities or number of GPUs. I don't think anything implemented so far, but yeah, definitely that's one direction we want to take, yeah.
All right, any more questions? Once?
Well, thanks for this. My question is slightly taking a step back. I was wondering if you can throw some light on what kind of problems prompted your team to start working on this TorchFix and related solutions.
What kind of problems to solve, or?
Yeah, right. So what kind of problems prompted you and motivated you to start working on TorchFix and?
What kind of problems do you have?
Yep.
Yeah, so that's what I tried to show in the beginning, right? Even this thing, right? You want to update Torch Kaleski to Torch Shaleski, right? So you need to change the name. You may need to update the imports. And also you need to look if it's like upper equals true what's there, then you need to add MH in there, right? You need to do Hermitian, take transpose basically. And this like easy, right? You just go and change it. But if you have like hundreds of thousands of files and millions or more lines of code, it's hard to even find this, right? So that was the motivation basically from the very beginning, to be able to update deprecated functions in the meta internal code base that use PyTorch. Because until we remove all these Torch-Shaleski calls from our code base and also other popular code bases, we cannot remove this function from PyTorch, right? So first we want to clean up the code bases of users, and then we can remove the function from PyTorch itself. And that was the initial motivation about deprecated functions. And the rest came later because we found there are more use cases. This like require grad or synchronized data loader or TorchVision. TorchVision also about, this slide is also about deprecated APIs, but this deprecated API is not in PyTorch itself, but in TorchVision. So this one is the initial motivation.
Hi, thank you for your talk today. I guess kind of a nitpicky question, but on one of the slides where you had the require grad versus requires grad example, why does require grad just pass without throwing any attribute errors if it is not supposed to be a valid attribute for autodiff backprop training of the models?
Yeah, because it's Python. Right. Yeah, we talked about Rust just a couple of minutes ago. Yeah, in Python, you create an object, right? And then you do object dot anything equals